Stars are wonders of the universe, not only providing light and energy, but also holding the mysteries of formation, evolution, and demise. Each star tells a story of life and death, existing not in isolation but deeply influencing the structure and development of the cosmos. Born from clouds of dust and gas, stars undergo billions of years of complex physical processes. This journey is not merely a physical one, but also a source of inspiration for profound scientific questions about the nature of the universe and our place within it. The birth of stars. Stars are born from clouds of gas and dust in the universe, known as nebulae. These regions contain vast amounts of hydrogen, helium, and cosmic dust particles, often spanning hundreds of light years. Initially, these clouds are in a relatively stable state, but an external disturbance, such as a shock wave from a nearby supernova explosion, can trigger a disruption. This causes particles within the nebula to be drawn together by gravity. As the gas and dust particles compress, pressure and temperature at the center increase. When the temperature reaches approximately 10 million Kelvin, nuclear fusion begins. Hydrogen is burned to form helium, releasing an enormous amount of energy. This marks the moment when a star is officially lit. Famous nebulae like the Orion Nebula are active sites of star formation. Astronomers use the most powerful telescopes to observe and study these regions, providing valuable insights into the early stages of a star's journey. The life cycle and evolution of stars. When a star is formed, it enters a phase known as the main sequence, the most stable and longest stage of its life cycle. During this phase, the inward gravitational force of the star is balanced by the outward radiation pressure from nuclear fusion at its core. The star shines steadily, providing light and energy to its surrounding space. Our Sun is currently in the main sequence phase and has remained in this state for approximately 4.6 billion years. Scientists estimate that the Sun will maintain its stability for another 5 billion years before transitioning to the next stage. After exhausting the hydrogen in its core, the star begins to age. At this point, the core contracts while the outer layers expand, forming a red giant. Stars like Betelgeuse, a massive red supergiant in the Orion constellation, exemplify this stage of stellar evolution. During this phase, the star fuses heavier elements like helium, carbon, and oxygen, creating a series of complex reactions before reaching its ultimate fate. The final stage of a star's life largely depends on its initial mass. Smaller stars with a mass less than 8 times that of the Sun typically end their lives as white dwarfs, a hot, dense core that no longer has enough energy to sustain nuclear fusion. On the other hand, more massive stars undergo a supernova explosion, releasing an enormous amount of energy in a matter of seconds, outshining an entire galaxy for a brief period. After the explosion, the remaining core may become a neutron star or, if the mass is sufficient, collapse into a black hole, one of the most enigmatic phenomena in the universe. Strange phenomena in the death of stars. The supernova SN 1987A, observed in 1987, is a classic example of the immense power of a star's explosive death. This event provided scientists with a wealth of information about the evolution of massive stars and their impact on the surrounding environment. Additionally, neutron stars and pulsars, with their incredibly dense matter and intense magnetic fields, continue to raise profound questions about the nature of matter and the fundamental forces in the universe. Neutron stars, characterized by their extreme density, are small but contain immense mass. A single teaspoon of neutron star material would weigh billions of tons. If a neutron star spins rapidly, it emits periodic beams of radiation, known as pulsars. A prime example is the pulsar in the Crab Nebula, which rotates at a staggering 30 times per second and emits energy millions of times greater than that of the Sun. Black holes, the ultimate outcome of massive stars, represent one of the most captivating phenomena in astrophysics. Their immense gravitational pull prevents even light from escaping, creating mysteries that modern science has yet to fully unravel. The role of stars in supporting life. Stars are not just sources of light. They are the chemical factories of the universe, creating the heavy elements essential for life. Carbon, oxygen, iron, all the elements that make up our bodies, are forged through nuclear fusion reactions within the cores of stars. When stars die, these elements are released into space, becoming the building blocks for planets, moons, and ultimately life itself. The journey of stars is a wondrous tale. From their birth in nebulae, their radiant existence lasting billions of years, to their dramatic deaths, they embody a miraculous cycle of cosmic rebirth. Stars not only help us understand the universe, but also connect us to the very origins of life. Continuing to study stars will open new horizons, bringing humanity closer to uncovering the profound mysteries of the vast cosmos.